Hello and welcome to AP Calculus BC Tutorials. Today I'll be going over the free response question from 2009, problem number 4. Here is question number 4. Feel free to pause the video for a couple seconds to catch up on the questions. Alright, solving part A. In order to solve part A, we need to use Euler's method as it states explicitly in the problem. As a review, Euler's method is a method to approximate a point on a curve using the equation of a point close to it. In order to find this equation, we need the x value, the y value, and the slope. In this example, we're going to use point-slope form. And we already have the x and the y values that we need, because we already have our initial condition of f of negative 1 is equal to 2. That means we can replace all x values with negative 1 and all y values with 2. But you'll notice that we're still missing the slope, and in order to find the slope, we need to use the differential equation dy over dx. In this equation, all we have to do is the same thing with point-slope form. Replace the x values with negative 1 and the y values with 2. Doing so gives us a slope of 4. And our equation becomes this. Next, we need to plug in our first step. To go from negative 1 to 0 in 2 steps, we need to go up 0.5 each time. So our first step is going to be when x is equal to negative 0.5. When x is equal to negative 0.5, we get that our y value is equal to 4. Therefore, we found that when f of negative 0.5 is equal to 4. But it doesn't stop there. We need to find the approximation of f of 0, which means we need to go into point-slope form a second time. You'll notice that we're missing our slope again, so we'll need to go back to the differential equation to find what our slope is. And we find that our slope this time is 0.5. Plug that back in, and plug in our second step, which is going to be when x is equal to 0. By plugging in when x is equal to 0, we find that our y value is 4.25, or 17 over 4. Therefore, our answer is 4.25, since we are looking for the approximation of f of 0. If we take a look at the scoring guidelines for part A, we find that we get 1 point for using Euler's method correctly with 2 steps, and another point for finding the correct answer. In this type of problem, the most common type of error are arithmetic errors, especially with ones that involve so many decimal points. But you can still earn 1 point from this problem, even if you get the wrong answer, simply by showing that you know how to use Euler's method with 2 steps correctly. And if we go back to question number 4, take a look at part B. Alright, so for part B, it's testing our knowledge of the Taylor polynomial format, which is given in this image. And since we're only finding a second-degree polynomial, we only need to find up to n equals 2. So let's start with when n equals 0. When n equals 0, the term equals 2, because we already know that f of negative 1 is equal to 2. The other values cancel out to 1, so all that matters is the y value, which is 2. Now, when n equals 1, the term equals 4 times x plus 1. We know that the first derivative of f of negative 1 is actually 4, because in the previous part, that's what we solved for. The denominator is still 1, since 1 factorial is equal to 0 factorial, which is equal to 1. But we notice that on the right side, there's an x plus 1 now, because since n equals 1, you bring it to the first power, making our term 4 times x plus 1. Finally, when n equals 2, the term equals negative 6 times x plus 1 squared. This might be the most trickiest part, because the denominator actually matters this time. The second derivative of f of negative 1 is negative 12, because it was given to us in this part. But the bottom of 2 matters, so negative 12 over 2 is equal to negative 6. On the right side, we get x plus 1 squared because n equals 2 now, so instead of raising it to the first power, we need to square it this time. Therefore, our whole term is equal to negative 6 times x plus 1 squared. If we add all those together, we should get our answer. When we look at the scoring guidelines for part B, we find that only 1 point is given, and that's for getting the right answer, which makes it nice and hard at the same time, because although there's not a lot of work you have to show for this problem, you really need to get the right answer in order to get the full point, which means you can't afford to make any arithmetic errors in between, and you really have to know your Taylor polynomial formats very well. Finally, we're going to move on to part C. Take a quick moment to read it over. Now, solving for part C. In order to find f of x, we need to take the integral of dy over dx. The simplest way to do that is to move the x's to one side and the y's to the other. That way, they don't get in the other's way when we take its integral. But it should look something like this. Next, what we need to do is actually take the integral of both to get this equation. Now you'll notice that there is a proportionality constant, or not proportionality constant, sorry, the constant of integration, which is c. And this is something we actually need to solve for because we're looking for a particular solution. We can get this constant of integration by plugging in the initial condition, which is f of -1 is equal to 2. All we have to do is replace the x values with -1 and the y values with 2. Doing so gets us the constant of integration, 1/3 minus ln of 4. And this is the equation we end up with. But it doesn't end there. We actually have to solve for what y equals, since the problem specifically asked us for something that y equals, not what y and something else equals. Therefore, we have to get y by itself. In order to do that first, we need to undergo a number of steps. First, we need to bring the negative to the other side. Then we need to get rid of the ln, and to do so, we need to raise everything by the 8th power. Notice how the ln4 and the e cancels out, so the 4 is brought down. The next step is a little bit trickier. We actually just drop the absolute value signs, but that's not always the case. You might wonder when you have to drop the absolute value signs and when you have to reverse the order. So in this case, it might be y minus 6. The reason why we drop the absolute value bars in this case is because when we plug in the initial condition, it works out just fine. But when you mix up the order, so it's that y minus 6 is equal to something, we get something a little bit different, and they don't match up. So therefore, that's a good way of knowing whether or not you can just drop the absolute value signs, or when you actually have to reverse the order inside first. And then from here on, we just need to move 6 to the other side and multiply it by a negative one more time to get what y equals. If we take a look at the scoring guidelines for part C, we see that there are a total of 6 points that you can earn, making it by far the largest number of points. Now, the first point you can get from separation of variables, which is simple, just moving x's to one side and the y's to the other. The next 2 points you can get from finding antiderivatives, and hopefully, if you're in Calculus BC, you should be able to take simple derivatives using u substitution at this point. The next 3 points are found using by finding the constant of integration and using the initial condition and solving for y. I think that the constant of integration and the use of the initial condition go hand in hand, because without using the initial condition, you can't actually find the constant of integration. I think most people would miss the solving for y part because most people wouldn't want to move everything over so that a pretty ugly looking equation would look even uglier. But it's actually necessary in this case since we're solving specifically for y. If we take a look at these 2 notes on the bottom, we find that there's a maximum of 3 out of 6 points if no constant of integration is found, which makes sense. And the second note here says 0 out of 6 if no separation of variables. So what this means is that you could find this specific solution of y, but if you didn't show your work and you didn't show how you got it by using separation of variables, you won't get any points because that's not showing the Calculus BC readers that you really fully grasp the concept, and they might just think you're extremely lucky or even possibly that you were cheating. So make sure you're showing your work and showing that you know how to use the separation of variables correctly. Alright, thank you for watching this video. See the description box below for more practice problems with the topics that were mentioned in this video.